Right, so another day, another question. This one, this is exercise 3 on paper 1. So let's walk it through. Find the term in x to the 6th in the expansion of x plus 2 to the 7th. Okay, before we go on with anything else, let's first talk about what's at stake here. This is very clearly a case of binomial expansion. I'm going to increase the font size a little bit, and on the basis that maybe you can't read it as it is there. But this is very clearly some binomial expansion that we have to do. So we have to remember how binomial expansion works. The way the binomial expansion works is that you have something like, for example, a plus b, and you take it to a power. I'm going to use the power n here because I don't want to say anything that's going to be only applicable in one situation. If you expand this, you can find that you can get an answer that looks like this. You will use NCR n comma 0 first of all for a to the n. Then you would say plus NCR, we start again, n comma 1. Then a to the n minus 1 times b to the 1. Okay, and then you start again. And you would have NCR n comma 2 a to the n minus 2 times b to the 2. And you would actually have to continue doing this until you had exhausted n, you had subtracted so much from it that n becomes 0, or sorry, not become 0, such that a to the n minus whatever, basically until you have this. Once you have that, then you must have b to the n, and that's the end of the expansion then, and there of course you would have NCR n comma n. This is the way that you do binomial expansion. It's very important to note a few things here. The first thing that I really want to emphasize is this multiply here. I know that it doesn't look like there's any multiplication in this, but the thing is that this right here, bringing it up to a power, is what brings in the multiplication. So you have to keep you have to do multiplications in here. The second thing that you have to keep in mind is this NCR. This is very, very important. Another thing that I really need you to remember as well is that it's the whole a. It's not just x's. It's everything that is found in this first part. It's everything found in the second part that goes into b and a. You have to keep the whole thing. Okay, so let's use this. Let's actually use this on our example, or sorry, not on our example, but on our exercise. So here, what we're going to do is we're going to try and do x plus 2 to the 7. Now, I'm going to do this, and I'm literally just going to copy what it says over here on the right. I'm going to do NCR 7, comma 0. And then I'm going to do x, because that's my a in this case. This is the a. So I'm going to highlight it with red to show that. And then I'm going to use green for b. So yeah, we've got x, and we take that to the n in this case. So that's 7. Now, then after that, we've also got NCR. And then we would have 6, 7, and then this time 1 further up, so 1. And then we have x to the 7 minus 1, so the 6th. That's from the from this first part, and then we have to keep in mind the second part, which is then times 2 to the 1. Now, we can continue, and normally I probably would, but because this exam question very specifically asks for the term x to the 6th, we're looking for when do we see x with 6 up here. Once you see that, that's the one that you want. So here, we can see, oh, this is actually our term. This is the one that we want. We would like to have NCR 7, 1, x to the 6th times 2. We do not care about all of the other things that you have to add to this. So all of this, not interesting. All the stuff before, also not interesting. So we only want to focus on this one. I'm going to show that by highlighting it in yellow, even though that'll probably not show up very well. But that's the one that we want. So we show this. Now all we need to do is figure out, well, what is NCR 7, 1? To find this, you simply have to do Pascal's triangle down to the 7th level. Now, I'm going to show you guys a trick here to avoid having to do 1, 1, 1, 1, 2, 1, etc. Instead of doing that, what you can do is you can go, oh, 7 and 1? Wait a minute, that's going to be the first thing. Now, if you follow, that's going to be, like, for example, these ones out here, like this one and this one and this one, they all belong to 0. They all belong to this second part here being equal to 0. The 1, however, it belongs to, for example, this one and this one and this one. And if you notice a pattern here, you might see that's very quick or very easy to know that this is going to be 7. Then you're going to have x to the 6th and then times 2. The only thing left to do is to simplify and see, okay, you've got 14 and then x to the 6th. Now, it says here term. When you see term, you need everything, including the x to the 6th. So here it will be 14x to the 6th. If I had said coefficient, which I'll write over here, if I had said coefficient, it would only be this part. Then I would only need to write down 14. But because I've said term, I need to include the x to the 6th. So this is for term, and this is for coefficient. Okay. So that's the first question done. We don't actually have to do any more expanding here. I mean, you might think to yourself, oh, but we haven't finished expanding it, but it doesn't matter. The only place where x to the 6th will appear is during the expansion we just showed. Okay, so let's move on to the next one. Hence, find the term in x to the 7th in the expansion of 5x times x plus 2 to the 7th. Oh, how interesting. So here, what we actually have is we would have to do our whole expansion, and then we'd have to times 5x with it. Something that I saw a lot of people try, but that doesn't work, is saying, well, this is the same as if we had just said 5x squared plus 10x. And while I can sort of understand where this comes from, it doesn't work. And the reason it doesn't work is because, think about what you're doing here. You're going from 5x to putting it inside. And when you put 5x inside, you take 5x to the 7th. You are having 7 times as many 5x's as you had to begin with. You are putting in an extra 6 5x's. It doesn't work. You have to leave the 5x until after you've expanded this. You must expand this, and then you may add this in. So our expansion here, if we do the whole thing, what we'll notice is we'll get 1 with x to the 7th, we'll get 1 with x to the 6th, x to the 5th, x to the 4th, 3rd, 2nd, and 1st. So we would get a 7, a 6, a 5, 4, and so on. Okay. The only one of these that when you times it with 5x, that would give you 1 more x, basically, enough for 7. You just have to add 1. So you would get 8. Then you would get 7, and then 6, and then 5, whenever you times in the x. So for example, let me try and show you what I mean. If you have down here x to the 7, and then you have plus x to the 6th, Those are the only ones I'm going to show. And then 5x times that. What you find is you would get 5x to the 8th plus 5x to the 7th. We are only interested in x to the 7th. That's what the question told us. So we're going to pay attention to that. And that means that we only care about this part, this result here. We only care about what it looks like when we times it with x to the 6th. So we'd keep in mind what our answer was from before. And then we say, okay, we say 5x times 14x to the 6th. And then we simply do this calculation, and we find that we get x to the 7th. But now let's do the complicated part. Let's actually multiply these together. So 5 times 4, that gives me 20. And then 5 times this gives me, I'm pretty sure it gives me 70 if I'm not mistaken, because you get 5 times 4, that's 20. And then you have to add 50 to that. So yeah, I'm pretty sure that this works. And this is actually the answer. Just as up here, this was the answer. Down here, this is the answer, where you have to include the 7th, because again, asking for term. We want the term. Coefficient is a different thing. Coefficient relates to term. Coefficient is in the term, but the term is the big one. Okay. So with that, that's actually our answer. I hope that it makes sense.